Yeah, maybe she will join. I think she has joined, I guess. Yeah, she's there. She's there. Fine. Girls, actually, I wanted to start with electrochemistry, but then few questions are there with me of our previous chapter, and few concepts are yet to clear. Let me finish with that then first.
Okay, ma'am.
Once we have done with this, definitely the next chapter which I'm going to start, that would be the electrochemistry. Fine?
Yes,
Okay.
ma'am.
Yeah, the questions are there in front of you. Try to solve this. Yeah. Any one of you who would like to read the question? Come on, speak up. Chandana, will you please read the question loudly?
The synthesis of alkyl fluorides is best accomplished by.
Ma'am,
Yeah.
it's option B, Schwartz reaction.
Schwartz reaction. It's already I have explained you, right?
Yes, ma'am.
Isn't it? So what would be the answer for this question? Oh my God, it's not connected. Give me a line. The pen tab is not connected with the laptop. Okay. So your option B is the correct answer. Schwartz reaction. Clear? Now go for the next question. The optically
Ma'am, it's option D.
Option
D.
D.
2-chloro-2-methyl butane.
Yeah, 2-chloro-2-methyl butane. You need to draw the structure for that, right? They ask you optically inactive. Means those are optically active, they should be chiral compound, right? A symmetric carbon should be present in that, right? So what they said, 2-chloro-2-methyl butane. What would be the structure for that? For the butane, number of carbon would be 4, correct? 2-chloro-2-methyl butane, correct? So CH3, this is CH2 and this is CH3, correct? So if you see this carbon, it would be at the center. It possesses two similar groups, CH3, and hence it is optically inactive because it have two similar groups. Clear? Yes, it's not a chiral carbon. Fine. Now go for the next. Which one of the following is likely to give a precipitate with AgNO3 solution? They have given you option CH3CCl, CH3 thrice CCl, then CHCl3, then CH2 double bond CHCl, and CCl4, carbon tetrachloride. The last one is the carbon tetrachloride, okay?
Ma'am, is it option A?
Why you think it's option A?
Ma'am, because among all these options, only that can provide a Cl minus ion in the solution. So, because it has stable
Carbocation, right? Yes or no?
Yes,
Because it is a tertiary carbon. This is primary, right? This is primary with allylic, right? And this is CCl4, it's a neutral one, right? Isn't it? It's a neutral one. So you will get here tertiary carbocation in this. Tertiary carbocation. And that would be stable one. And hence it will provide you Cl minus ion. And when it will be provide Cl minus ion, it will react with Ag present into the AgNO3 to give you AgCl precipitate. Right? Yes?
Yes, ma'am.
And because of that, option A is the correct answer. Fine? Shall we go for the next?
Yes, ma'am.
Yes, ma'am.
See the next one now. A solution of -1-chloro-1-phenyl ethane. -1-chloro-1-phenyl ethane in toluene racemizes slowly in the presence of small amount of SbCl5 due to the formation of. Check the answer and give me a while. Somebody is there at my door. Let me. Fine. The class is going on. Nice. Hello. Yeah, students. Yeah, what would be the answer? Hello, Chandana.
Yes, ma'am.
The fourth question, check. A solution of -1-chloro-1-phenylethane in a toluene racemizes slowly in the presence of small amount of SbCl5 due to the formation of what? Free radical, carbanion, carbene, or carbocation. Racemization would be formed by what? We know that two steps. First one, two different mechanisms we are aware about. That is SN2 and another one is a SN1. Correct? In
Ma'am,
SN,
is it
what
option
happens?
D?
Yeah. Why it is so?
Carbocation.
Yes. In SN2 we get an unstable transition state that cannot be isolated. Right? And in that, what happened? Inversion of configuration occur. And in SN1 only, your inversion happens, and in SN1 only racemization is happen, correct? Yes or no? And for racemization, both side attack on the carbocation is essential, right? So your answer must be carbocation. When carbocation is stable enough, suppose this is a carbocation, right? From the both side attack would be takes place, and hence your product would be racemic mixture. Correct? So your option D is the correct answer. Clear? Yes?
Yes, ma'am.
Fine. Go for the next. What is DDT among the following?
Ma'am, is it C?
Non-biodegradable pollutant.
Yes, ma'am.
Sure?
Yes.
What's the long form of DDT?
Dichloro, diphenyl, trichloroethane.
Correct answer. It's a non-biodegradable pollutant. Okay. It won't be a fertilizer. It won't be greenhouse gas. Greenhouse gases would be like carbon monoxide, carbon dioxide, methane, etc. And DDT will not be in that. Chlorofluorocarbon also you can include in greenhouse gases. Fine. Oh my God, already it's there. Our answer is there, I guess. Okay, no issues. I don't know how it's been remain as it is. Okay, we'll go for the next. Oh, I didn't remove the solutions for this. Okay, I'll hide it better. The compound form on heating chlorobenzene with chloral in presence of concentrated sulfuric acid is. Compound form on heating chlorobenzene. See, chlorobenzene you have to take, you have to heat it with chloral in the presence of concentrated sulfuric acid. Concentrated sulfuric acid, H2SO4. It will be gamexene, DDT, freon, hexachloroethane. Question 6. Chlorobenzene, chloral, in presence of H2SO4. This process is the formation for DDT. Keep it in your mind. If you want to write down somewhere at the backside of the page, that too fine. Or if you're making a running note, there itself you can mention. DDT is formed by what? Chlorobenzene with chloral in presence of concentrated sulfuric acid. Clear? Okay.
Yes, ma'am.
The next one. Iodoform can be prepared from all except. Iodoform cannot be prepared from. You have to identify. Means like among all four, three can prepare the iodoform and only one cannot. So which cannot, that you need to identify among the four. Iodoform can be formed by isopropyl alcohol, can be formed by 3-methyl-2-butanone, can be formed by ethyl methyl ketone.
So it's option C.
Option C, isobutyl alcohol, it cannot be prepared iodoform. Fine. So your option C is the correct answer. Clear?
Yes, ma'am.
That I'll give you the mechanism as well, but then that I will put into the resource material. From there you have to download. Okay.
Okay, ma'am.
I don't want to waste your time unnecessarily because we have to complete 2 more points from the chapters, like nucleophilic and electrophilic substitution of alkyl arenes. Sorry, haloarenes. And apart from that, one more thing about the alkyl halide, which we supposed to cover, that would be the elimination reaction. Okay, that's too easy. Beta hydrogen abstraction from the alcoholic OH group, right? That I have to explain you thoroughly. Then the next one, see what? Fluorobenzene C6H5F can be synthesized in a laboratory by heating phenol with HF and KF. Then from aniline by diazotization followed by heating a diazonium salt with HBF4, and by direct fluorination of benzene with F2 gas, and by reacting bromobenzene with NaF solution. How are you going to prepare fluorobenzene? Come on, think over it. Hurry up.
Ma'am, I guess it's option B.
Why it is so?
Ma'am, because when we like the synthesis of fluorobenzene from aniline is actually called as Ball's reaction, so it forms a primary aromatic amine. So
Yeah, because by heating
yeah,
phenol with direct HF will not be possible. It may it should be used like that, Lewis acid and all, right? And HF as fluorine is highly reactive, it does not we should not use that Lewis acid. We can use it for the bromine and chlorine only. Already we have learned about it, isn't it? Then the next option they have given direct fluorination of benzene with F2. It is highly impossible. Direct doesn't possible. By reacting bromobenzene with NaF solution, that is also not possible because fluorine is already electronegative. Your bromobenzene is also electronegative. So negative repulsion would be there. So what has remained? That is diazotization reaction. So you have to take a primary amine, that is aniline. You have to undergo diazotization, and whatever N2 positively charged ion you will get, that you can remove easily with HBF4. This HBF4 is nothing but the, we can say it's a isotopic for the Lewis acid, right? Yes or no? What it will be? HBF means HF plus BF3. HF plus BF3 it would be, right? So it become HBF4, right? Among that, one fluorine would be electron deficient and which get attracted towards the benzene. Understood?
yes, ma'am.
Kind of Lewis acid. Okay, fine. So your option 2 is the correct answer. I will move for the next question. Alkyl halides react with dialkyl copper reagent to give alkyl halides react with diallyl copper reagent to give. What does it form? Alkenes, alkyl copper halides, alkanes, or alkenyl halides. Which sort of reaction it is? See, alkyl halides react with diallyl copper, isn't it? Diallyl copper, how it will be? Suppose RCuLi, correct? Yes or no? What it is? R2CuLi, diallyl copper reagent. When it is treated with alkyl halide Rx, what you will get? This R and this R will be come together because this is negative, this is positive. But then here this copper would be positive and this R would be negative. Clear? Yes or no? So this positive negative R would be combined, they coupled with each other to form R and R. We have seen the Roots reaction. It's a kind of reaction. Same type of reaction it would be. You'll get RCu plus LIX. Clear?
Yes, ma'am.
Yeah. So this would be your product, that is alkane. So what you will get here? Alkanes. A similar kind of reagent is also there. I don't know whether you're aware of not. RMGX. What it will be? Grignard's reagent. Yeah. What is the name of this reagent? Grignard reagent. And this will be what? Diallyl copper reagent. What it is? Diallyl copper reagent. Right? And this is Grignard reagents. These two things you need to keep it in your mind. Only these two reagents are there in which your alkyl group is electronegative, because copper and magnesium are more electropositive as compared to your alkyl group in this case. Understood? Fine. And these are really very useful reagent for the preparation of number of compounds. Shall I raise? Girls?
Yes, ma'am.
Fine. Now we'll move down. 10th question. Yeah, the major organic compound formed by the reaction of 1,1-trichloroethane with silver powder is. The major organic compound formed by reaction of 1,1,1-trichloroethane with silver powder is. Options are there with you. 2-butene, acetylene, ethene, 2-butyl. Draw the structure first of all for the trichloroethane. 1,1,1-trichloroethane. Sorry. C, CS3, Cl, 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 1,1,1-trichloroethane, correct? Yes or no? This need to be reacted with what? Silver powder. What it will form? You have an option. Come on, tell me the answer. Let me see what your logic says.
Ma'am, is it option D?
Why it is so? Why option D? Why not ethene? Why not acetylene? Why not 2-butene? Why option B, butane?
Ma'am, because 2 moles of trichloroethane reacts with 6 moles of silver chloride, so it gives
It gives what?
tubutene.
Butane. It won't give butene, it will give you butane. Butane
Sorry.
means carbon-carbon, triple bond, correct? Yes or no?
Yes, ma'am.
So from this carbon 3 chlorine, from another like whatever 1 trichloroethane, 3 chlorine would go with this 6 AgCl. It will form 6 AgCl, and the coupling in between this carbon and another carbon would be happened. 1 chlorine when released, that time 1 single bond would be formed. Like that 3 chlorine has been released, that time 3 bonds would be formed in between these two molecules. Okay, and you will get your butane. Clear? So this would be what? Butane. Which butane? 2-butane, because at the second carbon there would be the carbon-carbon triple. Okay? The answer is 2-butane. Clear?
Yes, ma'am.
Fine. Go for the next. Aditi, are you there? Aditi, are you there? Okay. Question number 11. Aditi's text, I guess. Okay. Okay, your mic is not working. Fine, no issues. Elimination of bromine from 2-bromobutane result in the formation of 2-bromobutane. What would be the structure? Butane would be here, I'll write. Yeah. CH3, CH2, CH2, CH3. This is normal butane. 2-bromo means at the second position there would be bromine. 1, 2, 3, and 4. Balance has been satisfied. So what they said, elimination of bromine from 2-bromobutane result in the formation of what? Equimolar mixture of 1,2-butene, predominantly 2-butene, predominantly 1-butene, or predominantly 2-butene. What it will be formed? 1-butene, 2-butene. Think over it. And what would be the reason? Even you have to give me reason. This would be our 11th question, right? Hurry up, girls. You are taking too much time. Come on, tell me. Two possibilities are there, right? In this case, how many possibilities are there for the formation of compound? Two possibilities. This is your bromobutane. It has what? 2 alpha hydrogen. Here is also alpha hydrogen. Here is also alpha hydrogen. If hydrogen from this, suppose this is CH2 and H is there. If this hydrogen would be lost, you will get minus HBr, right? The product would be CH2 double bond CH, CH2, CH3. And if another case, I'll use the another color, so that would be convenient to understand what exactly I'm doing here. Suppose this is CH only, alpha, another alpha hydrogen. Here CH and here H means H2. Among that H2 and H I have replaced, as I have written in this manner, it's there at same position only. So this will form the double bond in between your second and third carbon, and your Br would be depart, and another product would be formed by minus HBr. You will get what? CH3, right? Then CH, double bond, CH, your CH3. So this is what your 1-butene, and this would be your 2-butene, right? So according to your SETZEF rule, which rule? Which rule, girls? SETZEF rule. What does it say? More substituted alkene is more stable. So this is a major product, right? And this would be your minor product. So your answer is nothing but 2-butane. It's given. Yeah, predominantly 2-butane. Option B is the correct answer. Clear? Hello?
Yes, ma'am.
Whatever I'm explaining, are you getting?
Yes,
Because
ma'am.
I wanted to communicate with you girls. It should not be one-way like process. Only I'm babbling in front of you. I'm explaining a briefing concept in front of you, and you're not reverting at all. It doesn't like fruitful, productive at all. Okay, you have to revert me.
Okay.
Fine. Yeah. Even you may feel bored, like ma'am only saying something and we are not like responding. Don't keep ma'am at all. Okay. If you have any doubt, you can ask. Fine. Or if you understand, at least say yes, ma'am, we understood.
Okay, ma'am.
Fine. Now we'll go for the next question. Question number 12. Yeah. Mesoisomer. Which of the following will have a mesoisomer? Mesoisomer, which substance would have a mesoisomer? Can you tell me? Mesoisomer would be have only to the compound which have a symmetry, plane of symmetry, center of symmetry, etc. So whatever options are given to you in front of you, 2-chlorobutane, 2,3-dichlorobutane, 2,3-dichloropentane, and 2-hydroxypropanoic acid. So draw the structure for these all 4 compounds and find out which one is symmetric, which has a plane of symmetry, and which one would have a plane of symmetry. That substance would be would must have a mesoisomer.
Ma'am, it's option B.
What it would be?
Option B.
Sure.
2,3-dichlorobutane.
Are you sure?
Yes, ma'am.
Fine. What would be the structure for that? 2,3-dichlorobutane. First of all, I'll draw the basic parent structure for the butane 1. Sorry, 2, 3, 4. Right? 2,3-dichloro. Here it will be chlorine. 3. 2,3-dichlorobutane, correct?
Yes, ma'am.
3. CS3. Then here it will be CH, and here also it will be CH. I can cut this compound from center in this way. Isn't it? It has plane of symmetry. And if it has a plane of symmetry, what does it has? A mesoisomer. Okay, please note it down. Clear?
Yes, ma'am.
Fine. Now next 13, the organic chlorocompound which shows complete stereochemical inversion during SN2 reaction is. It is there in front of you. Which one would show the complete inversion? 13th question. An organic chlorocompound which shows complete stereochemical inversion during SN2 reaction is.
Ma'am, it's option A.
For what reason?
Ma'am, like only primary halides show SN2 reaction more than secondary ones. So
Yeah, so you can check it. Rest all are either secondary or tertiary, right?
yes,
These.
ma'am.
And this is only primary. if you see about the SN2 reaction, rate of reaction is increases, like primary is more as compared to secondary, which is more as compared to tertiary. So primary would show faster reaction with SN2, right? And in SN2, which state is there? Transition state is there, which include, I think, 4 bonds. Among that, one is breaking, one is forming. So that will be half-half. And rest 3 bonds would be there with the alkyl groups, correct? Or else with a hydrogen group. We can say with the substituents. In this way, it would be. Correct? This would be your nucleophile. And this would be your living group. The transition state, correct? And if rest all would come in this transition state like this C2H5 2 groups and 1 hydrogen, then CS3 3 groups, then CS3 2 times and 1 hydrogen, it will be create a steric hindrance and rate of reaction will be decreases. So in this case, inversion will not be possible. Complete inversion will not be possible, correct? Due to unstable transition state. And hence your methyl chloride is the correct answer. Clear?
Yes, ma'am.
Yes. Fine. Now see the next 14th question. Which of the following on heating with aqueous KOH produce acetaldehyde? Sorry. Which of the following on heating with aqueous KOH produce acetaldehyde? Aqueous KOH and alcoholic KOH. There is a difference in between. What is the basic difference in between aqueous KOH and alcoholic KOH? When KOH is in aqueous state, OH group will be act as a nucleophile. Okay. And when instead of aqueous KOH, if there will be alcoholic KOH, that time this OH group will be act as a base. Right. So nucleophile will be attack onto the electrophile or carbocation. Okay. Or else in SN2, it will directly attack on the substrate. But then when it will be in a basic form, it will be abstract beta hydrogen to your functional group. This basic difference in between your alcoholic and the nucleophilic OH you need to understand. So aqueous KOH is nothing but nucleophilic KOH. So what happened in this about? Like how this nucleophile would be attacked on this substrate and which one would be give you acetaldehyde? What is the structure of acetaldehyde? First of all, check the structure of acetaldehyde, students. CS3, C double bond O, H, is it?
Yes, ma'am.
This will be acetaldehyde. And in IUPAC nomenclature, what does it call? Ethanol, correct? Its name is what? Acetaldehyde, common name. And its IUPAC name is ethanol, sorry. Ethanol, L it would be ethanol. Al for aldehyde. Okay. And ethane for these 2 carbons. 1 carbon and 2 carbon, correct? Yes or no? If you see here in the substrate, where it is here, 1 and 2 carbon are here, right? But then C double bond O is already exist. This Cl you have to remove it, which is quite impossible because chlorine and oxygen have a lot of affiliation, means affinity towards with each other. right? It is difficult to break. Now, if you go to the next, CH3, CH2, and only one chlorine is there, right? C double bond O is not present, and as only one chlorine is present, we are not able to convert it into double bond. If one more chlorine would be present, we can remove HCl and we can convert it into double bond, and after oxidation, we can convert it into acetaldehyde. Correct. But then this is not possible with only one chlorine. So this possibility is also ruled out. Then the next, this is the coupled product, right? CH2Cl, CH2Cl. Isn't it? Such kind of product would be for, this is dichloroethane, isn't it? So dichloroethane doesn't require for the formation of acetaldehyde. But then if you see CH3, CHCl2, like this, CH3, CH, Cl2, here Cl and here Cl. So one chlorine and one hydrogen from here would be removed, double bond would be formed, it will go, and if you oxidize it, it will be converted to your acetaldehyde. Isn't it? Yes? You will get ethanol or acetaldehyde by using this compound D. So your option D is the correct answer. Clear?
Yes, ma'am.
Fine. Shall I erase it? Aditi, are you there with us? Fine. Now check the next 15th question. I think it would be the last question. Actually, I wanted to explain you about the one more, like electrophilic substitution and nucleophilic substitution. But then I think time will not permit us. I'll try to complete. Let's see. When would be your next class? Hello, girls.
Ma'am, like tomorrow?
Yeah, that's okay. But then I have to conduct one extra as well. So I can wind it up with this. Okay, today
So
evening
Sunday
we have a
morning.
meeting and have a, yeah, today evening we have a meeting. I'll discuss with management and I'll let you know. I'll text regarding in your group. Okay.
Okay, ma'am.
Fine. Check it. In SN2 reaction, the correct order of reactivity for the following compounds: CH3Cl, CH2Cl. Then here it will be CH3 twice CHCl3, sorry, CHCl, and CH3 twice CCl is SN2 reaction correct order of reactivity. First of all, you should know what primary alkyl halide react faster in SN2. So primary would be this, correct? So this possibility, sorry, you are first, sorry, where it went? Yeah, this possibility is ruled out. This is also ruled out. Only remain these two, correct? Yes or no?
Yes, ma'am.
Now next one would be what? CH3, CH2, Cl. This is also primary, isn't it? This is also primary, but then this R group is quite bulky. So
Ma'am, so
CH3,
it's option C.
Cl, right? Yeah. So option C would be the correct answer, right? And then this one would be CH3 twice CHCl3. It would be secondary, isn't it? And this one is tertiary. This one, last. CH3 thrice CCl. So your option C is correct, is it? Yeah. Fine. Clear?
Yes, ma'am.
Somebody got disconnected. I think Aditi has got disconnected.
Yes, ma'am. She got disconnected.
Right, no issues. I hope you understood clearly.
Yes, ma'am.
Right. So what should I do? Shall I continue or will continue by tomorrow with the content which is remains? I think Root's reaction already I have explained through the examples when we saw a number of examples in that time only. So
Yes, ma'am. We'll continue tomorrow.
yeah, Grignard reagent and this alkyl copper reagents are there. Now that also I'll explain you thoroughly. And electrophilic substitution and the nucleophilic substitution only I have to explain. I guess rest all things we have covered up. Fine. So tomorrow
Okay.
we'll wind it up with this chapter. And then immediately we'll start with electrochemistry. Fine?
Okay, ma'am. Thank you.
Most welcome. Bye. Take care.